Thanks, Brian. As you have heard in my introduction, I'm one of the co-leads of the Theia project, and I take care of keeping the code tidy, so to speak. Lots of code reviews and discussions about what the code what good code should be. Excuse me. So, welcome to my talk about the Theia architecture, an overview of it anyway. Sorry. There we go. So what's in this talk? There's going to be a lot of talk about high-level mechanisms and very little about actual patterns on how to do stuff. There will be lots of graphics and very little text. And the talk is mostly aimed at people who are working with Theia source, be they adopters or potential contributors. And my hope would be that when you see some complicated code in the Theia source code, that you'll remember something from this talk and say, well, now I understand how it works or why that is here. So let's jump right in and look at the anatomy of a Theia application. You all know probably as Theia is basically a web application, excuse me, and it runs on a server. There's a backend. The backend is written in Node.js, an Express web server actually. And on the other side, on the client machine, we have a browser window, and in the browser window runs a single-page JavaScript application. And that JavaScript application is implemented with a framework called Phosphor.js. By single-page JavaScript application, I mean one where you don't follow links, but you always stay on the same page, and the JavaScript manipulates the UI as you interact with it. Phosphor.js was used because it's a framework that's focused on providing a desktop-like experience in the browser. In particular, the browser, it offers very responsive layouts that do stuff that you can do with CSS, like react to resize, etc., in the way you would expect from a front end, from a desktop application. You can see the arrows here. The front and the back end use both HTTP and WebSockets to communicate between each other. And one thing to note is that you can have multiple browser tabs or browser windows that are served by the same backend. And as I said, typically the front end and the back end run on different machines. But of course, today we have Electron. So if I want to, I can actually also take the front end and the back end and package the whole thing as an Electron desktop app. If we look a bit closer, there's actually two parts to the backend application. There's one part that serves the assets of the front end, the index HTML, the various JavaScript applications, etc., and CSS. And there's a second part that stands up a bunch of services that the front end application can talk to. In the graph, you can see there's service implementation objects. And on the other side, let's say on the front end, we have a proxy object, and the proxy object can actually invoke via JSON RPC, remote procedure call framework. It can invoke something on the service implementation in the back end. And the one thing that's special is that Theia multiplexes all those connections over a single WebSocket. It used to be different, but for efficiency reasons, we're doing it that way right now. And the other thing to note is that each front end or each browser window gets their own set of backend services, and we'll see more on how this is done later. Last thing to mention here is that both the front end and the backend applications have a startup point called the front end application or the backend application, and extensions can actually contribute to the lifecycle of those applications, so you can get your say when the application starts up. You can do stuff, and when it shuts down as well. So that's more a structural look at a Theia application. So let's look more at what it looks like graphically. And for that, let me quickly pull up a Theia browser window, right? This is what it looks like. I can click around my views, make them appear, disappear. I have a menu. Below, I have a status bar. And if we go back to the presentation, you can see that we have a couple of different areas that are distinct in that whole layout. The whole thing is managed by an object called the application shell, and it manages a couple of areas. There's a top area I mentioned where the menus go. This is fixed, and also a fixed area at the bottom where the status bar lives. And then we have a couple of areas in the middle that adjust size as you resize the windows or move the internal dividers around. There's a left and a right area that is usually used for parking views. And also the bottom area is the same, usually used for parking views, but then there's the main area where when you open an editor, it will go. There are specific ways to contribute to all these areas. For example, views, editors, menus, status bar items. You can make extensions of Theia that will add your own content to all these areas. All these items that we put in there, be they views, be they editors, etc., are widgets as far as the Phosphor.js framework is concerned. And the Phosphor.js and the application shell manage those views and take care of resizing, of moving, etc., and also orchestrates the saving and restoring of view state as you close windows and open windows, or you move them around. This looks a lot like what Visual Studio Code window would look like, but there are a couple of differences. One thing is that for us, the left area and the right area, oh, sorry, that didn't take. If I put it over here, are really the same. So I moved this view over here, but you can do different things as well. You can open trying to open the gitignore file here, but it's not working. Seems I'm offline. Let me, ooh. Live demo. Yeah, there we go. Reloads the browser window. So you can see this is a live demo and not some video. So funny thing is that the front-end application, you can see it's independent because it still worked. I could still move the views around. So I'm opening an editor here, and things like, for example, I can take this editor and I can put it, if I can put it over here and use a like view. The only thing that's different now is that when I do this, I have the editor here, but I can't close it anymore because this area doesn't afford closing. I can put it back, I can close it, etc. So this is very like a VS Code layout, but it's a bit more powerful. So back to the presentation. There we are. If we talk about Theia, we need to talk about dependency injection, right? Because that's a very important part. Theia uses a framework called Inversify.js to wire components together. And if we think about why we want dependency injection configuration and how it works, it starts by a consumer on the right. You can see it on the right side, and it has some other object it relies on to do its work. And the idea is that the consumer doesn't create the object itself and it doesn't look it up, but it defers which object it should use to a central component called the dependency injection framework or dependency injection container. And to help the DI container decide which object to use, it describes the object it needs with some metadata. That metadata can be an identifier, it can be an interface or a class that is needed. And injection targets like instance variables or constructor parameters are annotated with the metadata, right? So on the other hand, I have the application configuration, and there are a couple of rules in there. So for example, if I have two implementations of a service, I need to describe those services to the dependency injection container so that it can make a decision at runtime which of service implementation A or service implementation B it should actually inject in the consumer. Why are we doing it? The idea is that the consumer becomes independent of the context. And the cardinal example here is usually testing. So you have a different service when you have in production than in testing, where you might have a mock service. But there's also other use cases. For example, if you want to convert an application from single tenancy to multi-tenancy, and let's say you do a search among all the customers, you might change that just by injecting a lookup object to the customer search that doesn't look among all customers, but only customers of a certain tenant. So since we use Inversify, let's define some terminology. An object that is to be created by the dependency injection container and injected is called a service. There is a service identifier that says which service do we mean. It's just the name. It can, in Versify.js, it can be a class object, or it can be a symbol, or I believe also a string. And there's also the concept of a container. And the container is basically a scope where we look up dependencies. Because there might be multiple containers, and you can, when you want something injected, the framework will look inside the container you're asking to create the object, but not inside any other containers. There's one exception to that, a container can delegate to a parent scope container. So if the object is not found locally, it will be looked up in the parent container. And the last thing we need as a term is a container module. And in Versify.js, that's basically a glorified function that will add service bindings to a certain container. So you pass a container to that function, and you will add whatever you want in that function, you will add to that container. All right, so a couple of patterns that Theia uses. There's usually basically two basic patterns. The one is the service pattern, and that's quite a simple one. You have in Theia core, for example, there is a preference service implementation, which implements a preference service interface, of course. That is bound in the main container to the ID of the preference service, ID1 is here as an example, and there will be injection. If in an extension you want to use the preference service, you will depend on the Theia core module, and it will inject the preference service implementation here. The interesting here is that the flow of usage is the same as the flow of dependency. So the preference service implementation doesn't really know the objects that invoke methods on the preference service implementation. So the control flow is from the extension to Theia core in this instance. The second pattern is the contribution pattern. And it's kind of like the inverse. If I have a service like the file service in Theia, there are different implementations, and we don't want to implement all the different things that might be viewed as files in the core, but we want to delegate that to extensions. So what we have is a single service identifier where we might bind multiple contributions to. In this instance, we have a disk file system contribution, and we have an HTTP file system contribution. The important difference, or there are two important differences to what we've seen before. One is the one-to-many relationships, which usually is applies for contributions. So we have one file service plus multiple file service contributions. And the second thing is that the extended service controls the control flow. So the file service will use the file service contributions and not the other way around. So we talked a lot about customizing and configuring the Theia framework in Theia applications. And one of the important patterns here is that you can rebind a service that's already bound in the core to something else. So we have some service implementation, which is bound to a certain identifier, which is used in an extension. But now I can add a second extension. And this has a different implementation of the same service. And I can just rebind the service in my module, in my extension module. And everybody in the system that needs, sorry, the service will now use my re-implemented version. Right. Okay, next. So now we have seen dependency injection, etc. Now how does this actually work in Theia, that you can use extensions and dependency injection to customize stuff? A Theia application is basically just an NPM package that depends on one of the Theia packages. Let's have a quick look at the code for an example. I hope you can see the code all right here. It's a bit small for me. We have in the Theia source code, there are a couple of example applications, and one of them is the browser application. And if we look at the package JSON of that package, it has two things that are Theia specific. One is a block of configuration, but the second one is just a list of dependencies. That's the standard package.json dependencies list. And all we have here are dependencies on Theia packages. But you might also add your own extension packages here, of course. So second, if we look at what a Theia extension is, it's also an NPM package with a bit of extra markup in its package JSON. So let's look at one. Let's look at the file search package. If we look in here, you can see that it's a standard standard NPM package, but it has an extra tag here, and it says Theia extensions. You can have multiple of those tags, and that has a value for front end and for back end. And what this references to is just a JavaScript file that is in that particular NPM package. So let's look at it. We can look at the source code. It's easier. So if we look at here, and we look at that file search front end module, you can see that what we export here is actually just one of those container modules from Inversify.js. So how does this work together? Let's go back to the presentation. There is a build tool that is part of Theia that's called the Theia tool, And when you invoke build with these tools, it will actually go through all the dependencies in your application package JSON, and it will look at all the front-end and back-end extensions that are mentioned in those dependency package JSON files. And it will generate a front-end and the back-end application file that will load all these container modules into the main Theia dependency injection container at runtime when it starts up. Again, we can quickly have a look at the source code here. Again, back to our example application, and we can see there's like a source gen folder, which is created as part of the build. And there's a backend part here. And you can find all the backend and backend module NPM modules required here in this application. And the same holds true for the front-end application. There you go. I can't really see the file search example that we've seen, but it's in there somewhere, trust me. All right, I hope that's clear how that works. So once you generate that application, you build it as a Java application, maybe you webpack the front end, and then you end up with a Node.js application that actually pulls in all your extension packages, etc., with the Theia packages and initialize the dependency injection. Let's go back to the presentation. All right. So Remember, we talked about backend services, and now we talked a bit about dependency injection, and now we're going to put the whole thing together, and we'll talk about again about how a single backend can serve multiple front ends, right? And if you look at the different browser windows in Theia, they actually serve like they're independent applications. You don't get interactions between the different windows. So let's say we have the browser window with the front-end application, and it wants to talk via service proxy. It wants to talk to some backend service. The backend application detects that there is a new workspace, a web service or a web socket being opened, sorry. And in reaction, it creates a container module, right? And it puts with the main Theia container module as the parent, but the child actually will have the web socket instance bound to a certain identifier in there. And now, if we actually create service implementations, the service implementations will need a WebSocket to communicate over. And they will get this WebSocket injected inside this connection container module, we call that. So what the connection container module is actually a container module that will be invoked. And let's say remember it is a function, so it will be invoked each time with a different container that already has that WebSocket connection in there. So if we open a second browser window, we will again get a connection container module with the WebSocket in it and a copy of all the services, but this time bound to the new WebSocket that connects to the second browser window. And if that browser window goes away, the backend detects that, and it disposes of the connection container module and every service that's been created inside the connection container module. So far for that. Next, let's talk a bit about editor integration. And I guess a lot of you know that Theia uses the Monaco editor from VS Code under the hood. And the Monaco editor has a standalone version that you can just load into your page if you want to have an embedded editor on your web page. And it has the main editor, but it also has a couple of surrounding services included. One, for example, is the editor service. The editor service is a bit of code that lets you switch between different editors and keeps track of which editors are open. But there's also things like key binding service or a theme service, et cetera, et cetera. So this is not actually what VS Code uses. When VS Code uses the Monaco editor, it has the same basic core, but the services surrounding, like the editor service, key binding service, etc., they connect to the shell that is Visual Studio Code that connects to different views, etc., different UI, the menus, etc. So when we use Monaco in the Theia editor, we include it in the built front-end application, and we create it in a way that we pass different services like the editor service, like the key binding services that are specific to Theia and that hook into the services that Theia uses, or that Theia provides. There's also a bit of code that we use from VS Code that is not related to Monaco. And that's what we call the quick access service. It's what comes up when you press F1 and you can select type to find tasks or commands, etc. And there's also a bit of code below from VS Code for that. This is also why we don't use a pre-built Monaco package, which exists, but we make our own build and NPM package from VS Code that has all the parts that we need. In an ideal world, the editor, we wouldn't really depend on Monaco directly. And there's also a whole framework that manipulates editors in Theia that doesn't know anything about Monaco. And in an ideal world, all the surrounding services in Theia would go through that editor interface, and Monaco would just be one implementation of that interface. One example here is the editor service where it actually is true, but the second one is the plugin API. And the plugin API actually is not architecturally clean, so it's accesses and it knows that we have a monoquadret and accesses many of the services directly in the monoquadret and doesn't go through an abstract interface. This is an architectural compromise, but it was just much less work to implement it this way instead of introducing an abstract API and then implement it to hook up to Monaco. So last topic I want to talk about is plugins. And you might ask yourself, why do we need plugins when we already have all these extension capabilities that we've seen so far? And the number one reason is because plugins do not require recompilation. If you do an extension of Theia, as we've seen before, you need to recompile your product to add things. That's not what we want in many cases. We chose to imitate the VS Code model of plugins for three reasons. The first thing is you cannot add API at runtime, only at compile time. This is different, for example, from Eclipse, but it also makes for much simpler configuration and API management. The second thing is running plugins in a separate process like VS Code makes the main process, the UI process, much more robust against badly written extensions. The creators of VS Code had experience with Eclipse. They created it, many of them, so they knew how one bad plugin can take down your IDE. And the last reason, and it's a big one, is that we can actually use VS Code extension because we chose to implement the VS Code API. Again, so what's a plugin? A plugin at the most basic is a self-contained Node.js plugin. And by self-contained, I mean that it contains all the dependencies that it needs. It may also be webpacked to reduce the size because they might get quite big if you have lots of dependencies. If a plugin wants to access a certain API, it just invokes the Node.js require function with the API name. For example, require VS Code or require Theia. And the system overrides the Node.js require function to return an API namespace object instead of loading a module from disk. And that namespace object is hooked into services that will connect to the IDE. Theia provides one of the following API namespaces depending on how you package your plugin. One is Theia and one is VS Code. They're very similar except for the naming. For example, in the Theia API, we talk of plugins, and in the VS Code API, we talk of extensions. So how is it implemented? We've said that we want to run the plugin as a separate host process, right? So on the right, we see the host process. And let's say the plugin calls the register command API on the plugin API. And the effect we want to have is in the command service, a Theia service that is over here. But the plugin process cannot see the browser window, and the browser window cannot directly see the plugin host process because it doesn't expose any web interface, right? So what we do is we tunnel the communication between the plugin API and the command service via the backend. And as you would expect, if we have multiple browser windows, again, the plugin process is bound to that browser window with because the connection and the management of the plugin host process is done in a connection container module. And again, once the browser window goes away, the connection container module goes away and the plugin host process is stopped. So let's look a bit more closely at how this works. So again, we have the register command and we have a plugin API object and we have the command service on the browser window side. So the plugin API actually calls a command on a service proxy for a service that runs over here. This is the command main service proxy and the command main service implementation. It uses a class called the RPC protocol to encode that request into a JSON message. And that RPC protocol is relatively similar to the VS Code JSON RPC, but it's much simpler. And I guess that's why they did quite kind of a copy. Then that message is passed via inter-process communication to the backend process, and then to a backend service, which calls a front-end service and just passes the message on to another instance of the RPC protocol, which decodes the message and invokes a method on the command main implementation, which then hooks into the command service. And ultimately, something on the command service is invoked, right? So this is one way, but of course, it also works the other way, where the command service, for example, wants to invoke a command handler and sends the whole thing down the chain, routes it over through the backend process, back up the chain, and calls invoke handler in the plugin code. We can run the plugin host process in a separate Node.js process, but we can just as well run the plugin host process in a worker thread inside the browser. And this is what we call a front-end plugin, right? That's something that never goes to the backend. It all remains in the browser. And it looks very similar in that we also have we have the same command X service, command main service, and we use the RPC protocol, but instead of routing the whole thing to the backend through to the plugin host service, we just use the worker thread message passing interface to send messages to and from the plugin API. The API that's available in the worker thread is a bit smaller than the one that's available in the plugin host process, the full plugin host process, because some of the services are implemented using a Node.js specific API. We didn't do a second implementation, right? So one last thing to talk about is that because Theia is a framework or a platform more than an application, so it might make sense that your application has different needs for extension API. So you can actually add your own API namespaces. That would be the same as you would say require VS Code, you would say require my API or require J in one instance. And all you have to do is provide a factory that creates an API object. And it also needs to set up the required main X interface. We call this the main X interface, the remote service that where the plugin service talks to the front end, or the plugin host talks to the front end. And on the other side, on the browser side, you need the init function that sets up the main side services. And that's, with a bit of markup, is basically it. Fun thing is the custom namespaces can be used in parallel to default and other custom namespaces. For example, Che provides a plugin namespace to plugins that provides access to dev file information or which containers are running in the workspace. All right. That was a lot to absorb, but that's the end. Questions?
Yes, we do have a couple of questions, Thomas. So let's try right in. The first question was from me, actually. Maybe a naive question coming from a non-technical point of view. Is can and should Theia run other editors apart from Monaco?
I think partly it's going to be hard. Let's say it that way. You can probably not run a different editor and have the plugin, the default plugin API, because a lot of it is hooked directly into Theia. But there's nothing, if we cleaned up the architecture, it might work. But it's, as always, it's a lot of work, and somebody needs to have an itch to scratch. Does that answer the question as far as? Yeah.
Yes, it does. I guess we see a lot of not a lot, but some products, loading different IDEs into their environments, like swapping out either Theia or VS Code or or something else, right? But that's at a higher level, isn't it?
Yes, absolutely. I mean, as far as Theia is concerned, it's just an architect. We shortcutted the architecture that is there. In principle, Theia doesn't know which editor it uses. But in practice, we were lazy implementing it, and we called Monaco directly instead of doing it cleanly, right? But it has nothing to do with Theia versus VS Code.
Right. Okay, so another question. Can you provide an existing example of a front-end plugin?
Yes, there is an example. There is an example plugin. A real-life example, to be honest, I don't know right now. Usually the things that you could do would be, there's, for example, the JSON language server, right? Because it doesn't use anything from files. It only looks at the open file. So it doesn't need access to the file system from the backend, etc. So that might work. But I work with Che, so I don't know that we're using any front-end plugins. But maybe someone else has information about them using that.
Okay, time for more questions. Any other questions? Thomas?
I hope I didn't overwhelm everyone.
So actually a related comment here by Vincent. I missed the beginning of the answer question because of a lag.
Vincent is completely correct, of course. You can have other editors, but they're not going to be, let's say it that way. If you replace the text editor, it's not going to be immediately hooked up to the plugin API, right? Because that's hooked up into Monaco. But if you have a different editor, of course you can have different editors. But replacement is probably the key idea here.
One other question just popped into my head. Because it's so dependent on browser technologies and it's built on browser technologies, do you have any compatibility issues, browser compatibility issues? Like, is it supported in all the major modern browsers, Chrome, Edge? Obviously they're both based on Chromium, but then Safari, Firefox, etc.
Oh, not exactly my topic of predilection. I regularly use Chromium or Firefox. I don't know about Edge. Sometimes you have problems with compatibility with the OSs because you deal with file systems. But I would think that somebody tests for Edge, but I can't really answer that from the top of my head. I'm sure somebody knows.
Yeah, I follow along the issues in the repository, and I rarely, if ever, see any browser compatibility issues come in. So I guess that answers the question. Yeah,
I think these days a lot of these issues have gone away, and they're basically hidden be. Well, they are forcing you to, right? Sorry, just reading the chat. What I mean is this: today, a lot of the browser compatibility issues, they're actually hidden behind the frameworks that you use, widget frameworks or Phosphor.js, etc. So the level of problems that we're solving, I think, is different. It's we're solving problems at a higher level than that.
Right. Okay. Any other questions, Thomas?
I think either I explained everything perfectly or people are overwhelmed or bored. I'll take the first.
Yeah, definitely the former. Great, fantastic. So thank you very much, Thomas. Yeah. And we're going to, in approximately 4 minutes at the top of the hour, we'll transition over to next talk. So please stay with us. Thank you.
Yeah, just one thing. I was thinking of making this talk into a what's it called, a blog post or something. So I would be interested in feedback if things were left out that you would be interested, or if it's the wrong level or whatever. Drop by the community chat and bring it up.
Great.
Thank you.